Is it recording? Yeah. Okay, let's get started here. We have free response questions. Now, being that a lot of these free response questions are, graphical in nature, graphing, I just want to make sure, did you want to go over, for example, number 2, making that stem plot? Yes? No? Should we just do it? Yeah? Okay. So if I'm going to make the stem plot, I'm definitely going to put these numbers in my calculator. Is that app available to anyone else Crystal? Which one? Is that app? No, actually it costs about the same price as the calculator. Really? Yeah. Wait, what? The SmartView app?
Does it like connect to your... Hold on.
It does. It does. Okay, so I'm going to clear these lists. Can you remind us how we came to that point? Sure. So, stat clear list is number 4. Oops. You want to put the lists that you want to clear. So I want to clear L1, comma. I want to clear L2 as well. And I think that's all the ones I have to clear. Push enter and that kind of clears it up. L1 is second one. Second one. Yeah, I think so. I'm going to push stat, and I'm going to put all of those or those toe deformity angles into L1. So it's probably easier if someone just reads them. Can someone read them? Hmm? Yep. Uh-huh. Mm-hmm. Mm-hmm. 32, So that should be 38 different toes, or patient toes.
Is number 31 15 or 50?
31 is
50. 50. Okay. And to make life easy, quit and go to the home screen. And then you want to sort that list from small to big. So let's see, we can go to stat, sort A, that's sort ascending, put L1 in there, close the parenthesis, and that tells the calculator to sort L1 in ascending order, small to big. No. Or, no, we didn't have calculators in that. I'm smart.
Actually, you know, for like a good like 2 weeks before and after my AP test, I actually learned to use my calculator, and I never forgot. I love it.
Okay, and this really helps out because now when you look at the list, you can just kind of put this together. So I think for this style, let's not split the stems. Let's go ahead and just put these into the list. That's 13, 14, 16, 16, 17, 18, 18. So over here, this is question 2. So for question 2, I forgot 13, 14.
13, 14, 16, 16, 17, 18. There are 2 15s?
2 18s.
2 18s,
Yeah. Okay. And that takes care of the 1 stem. Next one is the 2 stem. So how many do we have in 20s? We got 20, 20, 20. Let's scroll down. How many 21s do I have? 4 21s. How many 22s? 122, 123, 123. How many 25s is that? 4, 3. 4 25s. What does that look like? 4 26s. And 3 28s. That takes care of the 20s stem. Let's do the 30s stem. We've got how many 30s? Look like 3. 31. We have 131 and 3 32s. We have a 34 and 2 38s. We don't have any 40s, but we're still obliged to put the 40 stem. And then we have 150. So that would be an example of what does it look like if you do not split the stems. Again, you're not in any obligation to split the stems unless you're asked specifically to do so.
What would splitting the stems
That look like in the back of the answer key.
Oh.
Those are splits. Okay, that's not what I meant to do. That's not what I meant to do either. There we go. That looks a lot better. Okay. Of course, you're going to need the key. So the stem is the tens place, and the leaf is the ones place. Next, using class widths of 5 degrees, create a table of frequency, relative frequency, and cumulative relative frequency. So we want angle, frequency, relative frequency, and cumulative relative frequency. So what was our smallest? Smallest was 13, right? Mm-hmm. So we're going to go from, first one starts at 10, and then we're going to go to less than 15. And that's just 2, right? That's the 13 and the 14. We're going to do the relative frequency and the cumulative relative frequency later. The next one's going to go from 15 to less than 20. How many is that? It looks like 5. The next one is going to be from 20 to less than 25. So let's count. That's 1, 2, 3. 1, 2, 3. That's 7, 8, 9. So that's 9 of them. Yeah, we're just counting. The next one is from 25 to less than 30. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like 11. And then from 30 to less than 35. That's 1, 2, 3, 4, 5, 6, 7. That's 8. Oops. $35 to less than 40. That looks like 2. And then even though there's no measurements here, we still got to put it in the chart. $50 to less than 55. There's only one of them. And that's where my chart ends. This should add up to 38.
We don't have to start at 0 and go straight to 10.
No, you don't have to start at 0. Okay, relative frequency. You're just going to take all of those frequencies and divide by the total. So this is going to be 2 out of 38, which is 0.5. Oops. This is going to be 5 out of 38. This is going to be 9 out of 38. 11 out of 38.
What do you want to round that next to the test?
4 would be technically what to do. Actually, let's just say that's what you're going to do. 4 decimal. 2 out of 38. 0 out of 38. 0 out of 38. 1 out of 38. That adds up to 1. Okay. So that's how we get our relative frequencies, just dividing every frequency by the total. Yeah.
On the test, do you have to do decimal or can you just leave it in the fraction?
Either would be fine. Yeah. Cumulative relative frequency. Yeah, the only place where you might want to, the reason why you'd want to change it into decimals though is for the cumulative relative frequency. So the first cumulative relative frequency would be 0.0526.
But you could just add fractions.
Yeah. But then when you make your cumulative relative frequency plot, it's a lot easier with decimals. 0.526, we're going to add to that the 1316. Gives me 1842. We're going to take that 1842, and to that we're going to add 2368. We're going to take that 421, and to that we're going to add 2895. And take that 7.7105. To that, we're going to add 2105. Take that 921. Add the next relative frequency to it. take that 9736, add 0 to it. Oh, and we don't get to 1, we get to 0.9999. But that's okay because that's just rounding error. No problem with that. And that takes care of part C. I'm sorry, that takes care of part B. Okay, that means that we need to get to our histogram and our relative cumulative frequency plot. So let's do our histogram first. Let's get a coordinate axis. Whoa, what is that? It's bizarre. There we go. And let's start labeling this. Should we go in frequency or in relative frequency, do you think? Relative. What's the biggest relative frequency? 0.28. Okay, so let's round that up. Let's make that 0.30. That make this 0.20. 0.10. Okay. And our first, we're going to indicate a break in the continuum. And let's see, our first one is from 10 to 15, is that right? 10 to 15? So 10 to 15, and then to 20, 30, 40.
How'd you go from 10 to 15 to 20?
Whoa, because I'm messing up. Good job.
It's okay, Mr. Ferrari, I forgive you.
Thanks. You should talk to my wife.
Mr. Ferrari, you're clear, man.
Again, Mrs. Ferrier doesn't agree. All right, 10 to 15, what's the frequency? 05, okay, 0526. And we make rectangles.
What do you mean 05?
0.05, yeah. All right, from 15 to 20? 1316. I've switched to blue, I don't know why, but let's just go with blue. 20 to 25? 0.2368. Thank you. 25 to 30? 289. Ugh. Wow, that's funny. 30 to 35? 0.21. 35 to 40? 05. 40 to 45? 45 to 50? 50 to 55. 026. Right. So that's my histogram. You can also do this in frequencies, that's fine. Yes.
Does it ever matter if it's in frequency or in frequency?
Only if it's specified would you have to use one over the other. If you're comparing two different distributions or two different distributions, then it would be more appropriate always to use relative frequencies rather than frequency. So that's that. Next one is our cumulative relative frequency plot. Let's get that done. Cumulative relative frequency. I didn't label the axes. What a jerk. So this over here is a deformity angle of deformity.
Would you be against just following the class? Do you want us to like write what it is?
I want you to write what it is.
Would angle be okay?
Yeah. Do not write class. And then this over here is frequency, right? Oh, my bad. Relative frequency.
Thank you.
Yeah. Huh? I actually climbed up on the table and tuckered them all out. That's what kind of hands-on person I am. This last one over here?
Yeah.
I'll do that when you all leave. Is that first one okay? The first? Okay. That is the best TV over there, by the way. Angle of deformity down here. Double slash mark to indicate that there's a break in the axis. And we're going to do pretty much the same thing. 15, 20. Let's see if I can remember to count by fives. What did I miss? 10. Do I need 10?
I mean, there's a group that goes from 10 to 15.
Okay. You're right.
Might as well just start with 0 then.
Where's my lasso? There it is.
I would just squeeze the 10 and more spaces left. Too lazy.
Okay, for the cumulative relative frequency, you're going to go all the way to 100, 50% right in the middle, and then I just leave 4 tick marks here. Okay, so the very first class goes from 0 to 15, and it starts at 10, so I'm going to put the anchoring point right here at 10, 0. And what is that first cumulative relative frequency? 0.0526. Okay. 0.526. What did I just do? Good. All right, then the next one. 1.8. And then after 1.8.
4.2.
4.2. 7.1. Okay, after 7.1.
9.2.
9.2. And it stays at 9.2 for a while, right?
Stays at 9.7 after this.
So I say that. So 9.7 after this. And it stays at 9.7 again. And then finally goes up to 0.99. Is that right? Yeah, that's close enough. And that's the cumulative relative frequency plot. If you do this right, most of the time it looks like an S-shaped curve. Okay. If you see a longer tail on the right side, that means your distribution is probably right skewed. And if you see a longer tail on the left side of the S, that would mean a left skewed distribution. If the two tails are about the same, then it's a symmetric distribution. So that's a good way to look at that. And that's question 2, right?
What do you say about the shape of this?
Yeah, if you know how they has the top part of the S right here. Notice how that top part of the S is longer than the bottom part of the S. So that indicates that you have a right skewed distribution. Okay. Do you want to look at the double? What is that? The I forgot the name of that. Back-to-back stem plot. Is that okay? Okay. And then the scatter plot of the children in the Ethiopian village. Any questions on the scatter plot? Do you want to just look at it, or? Yeah. All right, let's take a look at this. Question 4. Okay, again, we want to have our X and Y axis. Is that for us, do you think? Whoever's knocking? Thank you. Make that 15. 5 and 10. So this is age across the bottom. What was that? This is weight in kilograms. weight in kilograms. And then this is just like Algebra 1, 4.3. I'm going to use the boxes. 2 and 5.1. 3 and 5.7. 4 and 6.3. 5 and 6.8. 6, 7.1. 7 and 7.2. 8, 7.2 again. 9 and 7.2 again. 10 and 7.2. 11 and 7.5. And 12 and 7.8. Your choice of marks is not really going to make you or break you. I like using the squares because it lets me be off just a little bit. I have a little bit more error, or a little more tolerance for error with the box rather than putting in a precise little point. Don't forget to scale and label your axes appropriately. I think we did that. Okay. Questions on the scatter plot. How's the scatter look? Looking good? Good. Okay, I think all classes got to write about question question 3 for sure. Period 2 got to question 4. Did period 3 get to question 4? I don't think so, right? Period 3?
It was like the bell rang.
Question 4. Okay, let's take a look at.
I don't think we even started multiple choice. I think we started to.
I thought we did.
No, but I was just doing more preference.
Well, I mean, we can just start over again. You want to start over again, or are you good? Yeah. Question 1. Okay, so basically for question 1, I'd like to go through each one of these and categorize each one of these. So for part A, we have the number of people living in the household. That's the numerical response. That's numerical data. Letter B, we have the county of residence. That's not a number. That's a name. So that would have to be categorical. C, oh, categorical, letter B was correct, so we'll just highlight that one. C is household income. Again, that's a number, so that's numerical. D, age of the respondent. Yeah, that's numerical as well. And E, not euro. That's not correct. Okay, that's question 1. Most of the time people can categorize numerical and categorical pretty easily, so don't anticipate a problem there. Question 2, which one of these is quantitative? Square footage. Is it a number?
Yes, yes.
So it's quantitative. Oh, yeah. So it's quantitative. What did I just do? Quantitative. Numerical. B. B is a monthly gas bill. Gas bill is a number, right?
Yes.
This is also numerical. Is a number. Result. C is also numerical. C part B. And lastly, D can't be true. No, what am I saying? All were numerical. So all of the above. You all right?
Yeah.
Okay. 3. Why are you bold? Let's look at 3. We've got the percentage of high jumps. This is where we're looking basically at the last 2 bars, right? Only the last 2 bars are high jumps greater than, what was it, 85, 84? 84 inches. Those last 2 bars are about 37 and about 0.1. No, I'm saying it's 27, giving a total of 0.37 of the jumps greater than 84 inches. Okay. Basically, take those last 2 bars and add them together. Now, the only trick here is trying to locate where 84 is. And you want them to be greater than 84 inches, so that means 85 or greater.
How far off could you be on your answer?
84, 85, no, sorry. 37, 38, 39 might be okay. Although I don't think it looks like 39. On the other side of it, 36 would be okay. 35 might be a little bit iffy. If you're just writing it in, it doesn't particularly matter, as long as you're clear it's 37%. If it's obviously multiple choice, and you just go with what they give you.
The test is going to be the same format as last time?
Same format, yeah. Question 4, we have the number of burglaries in December 1989, which would be the last recorded point in the time plot. So you go to that time plot, you look at the last point on the right, then you use your pencil to rule over to the vertical axis, and that gets you to about, I don't know, 21 or 22. Okay. And that's 4. 5. Let's see. Which of the following is true? The number of burglaries in each month in 1988 is lower than the number of burglaries in each month in 1989. So let's see. 1989, all the burglaries are pretty... Well, let's see. What's the smallest number of burglaries? I think it's about 21. That's the smallest number of burglaries in 1989. Let's look at 1988. See, the smallest number of burglaries is, I don't know, it looks like maybe 10 or something. But the greatest number of burglaries is 35. So there are some months in 1988 that have more burglaries than some of the months in 1989. So A can't be true. B, the median number of burglaries in 1988 was a little over 25. Let's see. And I don't think that would be true, since most of the burglaries in 1988 are less than 25. So maybe I should write that up here for B. Since most of the burglaries in 1988 are less than 25, it's unlikely, impossible, for the median to be above 25. If the median is above 25, that means you're saying half of the months, or at least half of the months, have more than 25 burglaries, and at least half of the months have less than 25 burglaries, or equal to 25. C, the number of burglaries in 1989 is higher than the number of burglaries in 1988. I would say that that's true, since there were more burglaries per month in 1989 than there were in 1988. So C looks like it would be correct. Let's see. How do we write that? The number of burglaries per month in 89 were greater, for the most part, than the number of that has to be true, right? If per month there's more burglaries in 89, then there has to be more burglaries in 89. It's kind of the way that works. Let's see, for number 6, the maximum number of burglaries in 1988, that looks like that spike right at the end of the month. So like in December, like the quote spike. That spike is right around 35, right? The height of the spike is about 35.
Why did 2 inches number 5, sir?
What's that?
I was trying to remember the word for why did 2 inches number 5?
Yeah, I'm just kind of I'm trying to comment on all of those.
It was justified, yes.
Okay, so I think we're on 7 now. Let's check that out. Professor records the values of several variables for each student in her class. Which of the following is categorical? Score on exam? Not categorical, right? That's a numerical result. The final grade? That's a letter result. So that sounds like it's categorical. The total number of points, again, that's a number result. So we're looking at numerical for C. D, the number of students, the number of lectures a student missed. Again, that's a number result. So only one of these results that is not numerical in nature would be the final grade. Everything else is a number. So all the responses are numbers except B, right? And that's usually a good sign of whether or not something is numerical or not. Although not all number results are numerical, because numbers just have to have some kind of a meaning. If you sort them out, there should be a meaning to the way you sort them. I don't know if that makes sense. Large numbers mean something different than small numbers, as opposed to something like zip code, where if your zip code is 91332, that should mean something differently, or that should correspond to something, rather than if your zip code was 90013. The numbers don't really correspond with anything, right? Yeah.
Are phone numbers categorical or numerical?
Sounds like it would be categorical, because the numbers don't really correspond to anything. Let's look at 8. Okay, when drawing a histogram, it's important to, have separate class intervals for each observation to get the most informative plot. That doesn't make sense, right? That would mean that if you have 100 responses to your poll, you're going to create 100 different bars. That's not right. Let's see, make sure the height of the bars exceed the width of the class intervals so the bars are truly rectangles. That sounds like baloney, right? You got to make sure that you have rectangles. No, doesn't. That's not a concern. C, you want to make sure you label the vertical axis so the reader can determine the counts or percent of each class interval. Yes. You want your reader to know exactly what you're measuring here, whether it's a relative frequency or a frequency. Lastly, which this one can't be correct, but make certain the mean and median are contained within the same class interval, so the correct type of skewness can be identified. Yeah, that's never a concern at all. You want to make the histogram first and then assess skewness after you make the histogram, not try to manipulate the data so that your mean and your median are in the same class interval. It's not what we do. Okay, so C, correct answer for that. Let's take a look at 9. Okay, we have histograms for 9 and 10, and the question that gets asked all the time is, why are there 2 histograms for the same data? And the answer is, it's to confuse you, obviously. These histograms both represent the same data, and your job is just to basically figure out which one of these is more appropriate to the question, to answer the question. So the first one is, which interval contains half of all of the observations? So half of the observations, there are 25 observations. So fewer than half would be anything less than 12. So let's see, from 20% to 30%, is that less than 12 observations? Let's see, 5 and 3. So That's less than 12. That's fewer than half. Does that make sense? 25 to 40. 25 to 40, that is 3 plus 5 plus 5. That's 13 observations. That's more than half. So B is wrong. C? Okay, so I'm looking at where 25 is on the left graph.
Yeah. Why should I
Yeah, 25 isn't on the right graph at all. So it's easier to read 25. Yeah, that's what I'm saying. This is so that you can select the most appropriate graph to answer the question. So on the left graph, from 25 to 30 is 3 observations. From 30 to 35 is 5 observations. From 35 to 40, that's another 5 observations. Total of 13, which is more than half. The next one is 22.5 to 37.5. I have no idea where that would be. .5 to 30 goes by 7.5. Okay, so 22.5 then should be so we're looking at the middle two bars then.
It would be 8 and then
8, that looks like about 5, right? 8 and 5, that's 13. Again, the middle two bars there. And then 30 to 45, same idea. 5 plus 5 plus 1 plus 2, that's 13. 13 observations, more than half. So the correct answer was, what was the correct answer? Was it A? A, okay. It's A. It's gotta be A. D?
No, but number 9 asks for the.
Oh, it's number 10.
Oh yeah, we're on number 10.
It said on the answer sheet that number 10 is D.
30 to 45. Oh, it is D. I did 30 to 50. 30 to 45 is 5 plus 5 plus 1, which is 11. So yeah, D. What was 20? A is 5 plus 3 plus 5. Yeah, that's not right. It has to be D. Are you okay with that? Yeah. When creating a scatter plot, one should use. Okay, do we use a horizontal axis for the response variable? Yeah.
You still didn't do number 9.
Number 9?
Yeah.
Okay, so we want what percent of schools have an acceptance rate less than 20%? So where can I read 20% easily? Is that the first graph or the second graph? Yeah, left graph, we're looking at 20% is acceptance rate. And how many schools is that? Less than 20%. Yes, 4 schools have an acceptance rate less than 20%. 4 out of 25 is about 16%, right? So 16%. 4 out of 25. Let's take a look now at question 11. Creating a scatter plot. Do we need we want to use a horizontal axis for the explanatory variable. We want to use the vertical axis for the response variable. So A is wrong. B looks correct. We do want to use a horizontal axis for the explanatory variable. I should write that down, huh? 11. We want to use the horizontal axis. Wait, what did I just do here? Use the horizontal axis for the explanatory variable. Usually time. use the vertical axis for the response variable. Okay. Let's see. C, use different plotting symbols depending on whether the explanatory variable is categorical or the response variable is categorical. Well, if you're making a scatter plot, both of those variables should be numerical. So it makes no sense to have one of them be categorical. Use a plotting scale that makes the trend overall trend roughly linear, and that's actually really discouraged. You don't want to make your plotting scale anything other than straight, what's the word we're looking for? Yeah, constant, basically. 1, 2, 3, 4, 5, 6, 5, 10, 15, 20, whatever you need to do to make the plotting scale consistent. So yeah, that's it for 11. 12 is a pie chart. We know how much I love pie charts. At least you don't have to make a pie chart. Let's see. Consumers Union measured the gas mileage in miles per gallon for 38 cars, 78, 79 model automobiles on a special test track. The pie chart below shows information about the country of manufacture. Based on the pie chart, we conclude that, well, first of all, notice that there's a lot of information here which is not really important, right? They talk about the mileage, but the mileage doesn't really appear anywhere in this data. It's basically saying how many cars came from which country. That's all this is saying. So, Japanese cars get significantly lower gas mileage. You can't read any gas mileage from this pie chart. It's just what percentage of cars came from which country. US cars get significantly higher gas mileage. First of all, I will never believe that. Second of all, no mileage information appears in this pie chart at all. C, Swedish cars get gas mileage that are between, okay, how many cars came from which country? Yeah. Say, let's see, Swedish, more things about gas mileage. Mercedes, Audi, Porsche, and BMW represent a quarter of the cars tested. How would we know that?
They're German, they're all German.
Are they all German?
Yep.
Okay, so so are German cars about a quarter of the cars tested? No. Even if those were the only German cars that were tested, it's still less than a quarter. You can tell because, well, that's less than a quarter of the pie. More than half the cars came from the US. Yes. Clearly more than half the cars came from the US. You can tell because, well, that's more than half the pie. If I was going to eat a pie, that's more than half the pie. Oh my gosh. I bought pie over the weekend and I haven't eaten it yet. Double crust apple pie. Which one? Any pie? I like pies more than I like cakes. I wish it was a birthday pie rather than a birthday cake. Huh?
It's a whole debate between people.
Really? Pie versus cake?
Yeah. When's your birthday? We'll get you a pie.
April.
I'll buy you pie tomorrow.
26.
Alright, I'll remember.
Every day leading up to April 26th from now on, you'll buy Mr. Ferg.
No, because I won't be able to fit in my pants anymore. That's not fair.
Where you were.
It's a Thursday? You know, I might take it off. because I can go surfing. No. I mean, not in a long time. Yeah.
Take it off anyways.
Take it off anyways and go to the beach. Have some fish tacos. Let's finish this out. 13. The following shows the number of ounces of alcohol. 1 ounce is about 30 milliliters. Thanks a lot. Consumed in a week in a sample of 150 students. I assume this is for a college class. Okay. Let's see. Study wished to classify students as light, moderate, and heavy and problem drinkers by the amount consumed per week. About what percentage of students are moderate drinkers? So let's say consuming between 4 and 8 ounces per week. So the first thing to note is that this is a cumulative relative frequency plot. Right? What percentage drink less than? This is actually one of the fun parts about stats. It's all about death and like problem health. Right? Problem. We need to make like I'm gonna before I retire, I'm gonna make a test that's all about STDs. 100% STD test. That'd be hilarious, right? So let's see. What percentage drink less than 4 ounces a week? About 20%, right? 20% drink less than 4 ounces per week. Don't get me started on that OZ business too. Why the hell is OZ an ounce? Okay, how about less than 8 ounces a week?
That's like
60%? So 60% drink less than 8 ounces a week? 60 minus 20, yeah. Therefore, what is that, 40%? Per week. I can't wait till we get to the dead manatee question. Yeah. There's a question about dead manatees. Huh? No, Mrs. Ferrier would get jealous. Actually, she'd probably say whatever. Let's see. The histogram is for the actual frequency of closing prices on the NYSE of a particular stock based on the frequency histogram for the New York Stock Exchange. I don't know why you didn't capitalize exchange. The 80th percentile would be, okay, how many closing prices do we have? Let's see, 13 plus 8 plus 15, it's 50? 7 to, okay. For a total of 50 closing prices. Okay. The 80th percentile, so this is where we have to do math, right? 80% of 50, that's 40, right? So we need to find the 40th from the bottom closing price. So where is the 40th from the lowest closing price? So that's the real question. 40th from the bottom. Where is it? See, 13 plus 8 is 21. So 21 stocks, there's 21 of the closing prices for less than 20. 36 of the closing prices were less than 15. Yeah. Let's just start from the bottom. 13 of the closing prices are less than 10. 21 closing prices are less than $20. 36 closing prices are less than $30. 36, and then 7 is 43, right? 43 closing prices are less than $40. That is all sorts of wrong right there. Therefore, the 40th percentile is between $30 and $40. Is it? Oh, 80th percentile. 80th percentile is between 30 and 40.
You think this histogram is a
Right skew. Right skew. Most of the closing prices are small, so it's a right skew distribution.
So it's skewed with his lines of information.
Yes.
That took me a while.
Which one? 14. Well, we're looking for the 80th percentile. The 80th percentile would be the 40th lowest closing stock price. Okay. 40th lowest. So the smallest 13 are less than $10. The smallest 21 are less than $20.
Oh, yeah, you can also just do 40 at 50.
Absolutely, yeah. Go the other way around and start with the bottom top 10. Same thing.
If it's not skewed to the right or to the left, what is it called?
It could either be symmetric or a uniform.
Will that be a question?
I don't think it should be.
I don't know what to do.
Okay, I'm going to shut down and upload to YouTube.
Alright.
And then email.